This is the disappearing dots 2 experiment. There is a disappearing dots experiment, which you may want to look at as well, but this is related to it, but it is a different experiment. This teaches us about how we see things in certain ways. Okay, I'm not going to say any more than that because I want you to do the experiment. What you're going to need is some graph paper, okay, some graph paper. Now, as you can see here, I've got this one with quite fine lines on, but you can try different types, okay, so different types. Maybe you might want to use one where the lines are easier to see, because these are quite faint lines. So graph paper. I want you to use a felt tip pen for this. I'm using a black pen for this particular experiment. I want you to draw a couple of simple things, really simple, on the paper, okay, so watch carefully. I'm going to draw an X there, okay? About 7 squares across, I'm going to draw a little dot. So 1, 2, 3, 4, 5, 6, 7. Well, actually I said about 7. I'm going to go exactly 7, and I'm going to draw a little dot there, okay? That's the artwork out of the way. Now here's the experiment. What I want you to do is stand and hold in your right hand the sheet of paper, okay? And I want you to hold it about arm's length, at least 30 centimeters away, okay? And with your left hand, I want you to cover your left eye completely so you can't see a thing. Keep your right eye open and look at the X that you drew on the left side, okay? At all times, keep your eye glued to the X. Do not look away from it. Look right into the center of the X and do not move your eye from looking at that point. While you're looking like that, without moving your vision from the X at all, I want you to slowly bring the paper towards your eye, very slowly. Now, although you're looking at the X, of course, you'll be able to notice the dot across to the right. Even though you're not looking at it, you'll notice it. And I want you to be aware of that at all times. So keep noticing it without actually looking at it. Keep your eye glued to the X, as I've said already, but notice at all times what's happening with the dot. It's easy to do, just don't have to look at it. Keep moving it very slowly. I want you to take about 20 to 30 seconds to bring it to your eye. Okay, once you get to about there, just go back the other way again. Notice how slowly, it's very important to do it slowly. Remember, all times I'm concentrating my eye on the X itself, and I'm aware of the dot. Okay, that's it. Have a go. Okay, so again, I'm not sure exactly what you noticed, but I'll tell you what I noticed. I noticed that when I got it to about, let me do it slowly again, to about here, the dot seemed to disappear for me. About there, that's it. I can't see that dot anymore. I'm looking directly at the X at all times, remember? But I'm not aware of the dot anymore. It seems to have vanished. Notice how far it is from my face. Or from my eye in particular. Keep moving it closer, it's appeared again. Move it back out. It's vanished again. I can't see it. Oh, there it is again. Come back again. So at that position, I can't see it at all. It seems to have disappeared from my vision. What's going on? So, what's going on? By the way, probably some of you were saying, just a minute, I could still see it. It looked a bit more fuzzy possibly, but I could still see it. Now, look at how big your dot was, because some people do find it easier to do where it vanishes more easily with a much smaller dot than what I've done here. So if that was you, if it just went a bit fuzzy but you could still see it, how about redoing it, just so you know what I'm talking about, by doing a much smaller dot. Maybe get your pen and just literally do like a full stop, just pop. So that's all you can see initially anyway, and try it again, and I think you'll find it will actually disappear for you. But either way round, how come? It's there. Even if you do a tiny dot, it's still there, so where's it gone? How come your eye doesn't see it when you do it in that particular way? Well, you need to know that in the back of your eye, right in the back, if we imagine that's the back of my eye here, all over the surface there are millions of little light sensors, both eyes. Some scientists reckon it could be about 130 million light sensors in each eye. Amazing. All over the surface. But there's one part of the eye where there aren't any. And that's because all these little light sensors, they're all connected to nerves which send the information eventually to your brain. But they can't all zoom out your brain in one big fat tube and go into your brain. What happens is they all gather together behind the retina, behind the back of the eye. They all gather together and feed into one bigger optic nerve. It's not huge, but it is bigger, and it goes out through the back of your eyeball. Now, if you're looking at me right now, the optic nerve on my right eye would be leaving my eye towards the back. I'd be pointing at it about now, towards the back, towards my nose, about there somewhere. I'm pointing at it. It's not actually on my eyeball there, it's actually in the back of my eye. I'm pointing to where it would be going out of my eyeball. My left eye is about there. So both of them be leaving my eye, going out the back. Now where that optic nerve leaves the eye, that surface there is called the optic disc. Now on the optic disc, because of the optic nerve, we can't have any light sensors there. They just can't be there. Some people call it the blind spot, and you may have heard it by that name, the blind spot. And if you've heard that name and didn't know what it was about, that's what it is. It's a part on the back of your eye where there's no light sensors. Think about it. When you look at an image, everything that you're looking at, the image goes through your eye, through your lens, and your lens projects that image onto the back of your eyeball. So a little picture effectively appears on the back of your eyeball. And all the bits of that picture are sensed by all those millions of light sensors I mentioned. However, some of the image you look at, of course, must be landing on that blind spot. In this particular experiment, when I got it to there, for me, when that dot disappeared, that's because the image of the dot was actually landing on the blind spot. Therefore, I couldn't see it, and that's why it disappeared. But here's something else more interesting that I didn't mention that you may have noticed. Not only for me did it disappear, but it also looked to me like it was just complete graph paper there. All the lines seemed to be there. There wasn't like a fuzzy blob of nothingness. To me, it just looked like the graph paper was there without anything written on it. Now this gives us a clue about how your brain deals with it. Because you're probably thinking, just a minute, if I've got this blind spot all the time, how come I don't see a blind spot all the while? Well, in a way you do, it's always there, but the reason you don't notice it is two things. First of all, you're moving your eye around a lot, so you wouldn't notice it easily anyway. The other thing is you've got another eye. And because the blind spots are in different place, whatever I can see that lands on that blind spot, where that blind spot can't actually see it at all, can be seen by this eye, because the blind spot is in a different place. So normally your brain combines the two images anyway, so it puts it all together and you don't notice it. Of course, on this experiment, I'm only using one eye, so your brain can't do that anymore. So what it does instead is, well, it does it anyway usually, but it does it especially well now. It thinks to itself, okay, well I've got a blind spot here, I've got something I can't see, so what I'm going to do is fill in that little space that I can't see with what I think should be there. And remember, it hasn't got any help this time from your left eye, so it thinks really hard, thinks, right, what should be there? And what we think's happening is your brain looks at what's around the blind spot, all the image that's landing on the bit around the blind spot, and your brain thinks, okay, let me look at that, and let's see if I can figure out what it could be based on what I can actually see surrounding the blind spot, and fills it in. Now in my case, obviously my brain decided that when I got to that point where the dot disappeared, about there or so, my brain thought, uh-oh, can't see anything, there's nothing here, but I can see all this graph pattern around it. So I know I'll just fill it in with a graph pattern. And that's how come the dot disappeared but was replaced by the graph pattern. Okay, so what other things could we try? Well, the most obvious thing straight away is change the measurements between the dot and the cross that I've drawn. Remember, I drew them 7 centimetres apart from the centre of the cross to the dot. How about changing that? Make it a different amount. What about using your other eye, of course? That's another easy thing to do, isn't it? Just try the other eye. Do the same thing with the other eye. I wonder which way around you'll look at which. Have a think about that one. What about using bigger things on here? For example, a bigger cross, a bigger dot. Now, I've already mentioned one of the issues with the size of dot, but try it out for yourself, because maybe you didn't notice what I was talking about. So try a much smaller dot, like just a full stop, and maybe a big dot, like a disc shape or something like that. What about using different colours? Do you think that could make a difference? This is easy to see, black line. I wonder what would happen if you use a different colour. What about, instead of using this graph paper with these very faint lines, and as you've seen this has got lots of tiny little squares drawn within the main lines, so these have got 1 millimetre gaps between them. How about using that graph paper where it's just 1 centimetre squares with no little tiny divisions within them as well? Okay, so try that sort of graph paper, see if that makes a difference. And there are other types as well, so maybe find other types of graph paper with different sort of patterned lines on and try those. What about using a clean sheet of paper, maybe white sheet of paper, just exactly the same measurements we've used here. Remember, if we change one thing, you should leave everything else the same. So draw a cross and a dot, 7 centimetres apart, but this time on a clean blank sheet of paper, white paper. What about using different coloured sheets of paper? So don't use white paper, use blue or brown or whatever paper you can get. What about shiny surfaces? What about, say, a piece of baking foil, cooking foil? Again, you'll probably need a special pen for that, but they're easy to get. So draw a cross and a dot there. What about other shapes? I'm just using crosses and dots here. I wonder if you change the shapes, especially the one that we're interested in, the way it disappears or not. Don't do a dot, do some other shape, see if that makes a difference. And I'm sure you can think of some other things too.